Hello. In this lecture, we will look at an example that we discussed in the previous lecture. So, like we mentioned in the previous lecture, this firewall is hiding the IP address of the IGE gateway, which is 10.1.1.2 behind 172.16.1.5. This is the initiator of the connection, YOS3 in this case, and its source IP address is 172.16.1.2. To initiate the IPsec tunnel, it will send to destination address 172.16.1.5. This address will basically get translated by the ASA. And it will get sent out to 10.1.1.2. The address of YOS2. So, if we look at YOS2, let's do show run section crypto. It has 172.16.1.2 as the peer for the connection. And then the only thing that I'm doing right now is basically, I have a loopback interface of address 10.5.0.0/24. And I'm going to basically use this loopback on both sides to create the tunnel. So, if we see here, the crypto matches on access list 100. Which matches on traffic from 10.500/24 to 10.600/24. If we look at the initiator of the connection, which is YOS2, this one is configured for the IP address of the ASA NAT address of 172.16.1.5. The other side access list matches on traffic from 10.6.0.0/24 to 10.5.0.0. This is just from loopback to loopback. I configured it this way so I can easily initiate the connection. Let's do show IP interface brief. So let's clear any existing crypto sessions here. And here as well. And then if we look at the ASA, basically the ASA configuration is pretty simple. It just has a NAT configured, which NATs traffic from 10.1.1.2 to 172.16.1.5. This is a static NAT. For the show access list, we have an access list on the outside interface. This access list allows traffic to come into 10.1.1.2. If you're not familiar with the ASA, the access list allows the post NAT address. If we do show connection, we see nothing. So, in order for us to see what happens, let's go ahead and run a packet capture. So, we have a packet capture going on right now. We'll go ahead and trigger the connection. We will do this by doing a ping to 10.5.0.1, which basically pings the loopback on the other side, sourcing it from 10.6.0.1. So, we see here the ping is successful. If we look at the packet capture, we will see that we have the 6 ISA camp messages. If we look at the first message, this is from this router YOS3 to the 172.16.1.5, which is translated to 10.1.1.2. If we see here, we will see that the initial message, it has the SPI initiator enabled, and then it basically advertises NAT traversal vendor IDs. This lets the remote side know that it supports NAT traversal. So that's the first message. The second message. Also, this side advertises its NAT support. It states that it supports NAT traversal. So based on this, now, the two sides support NAT traversal. So now, message 3, basically, it will send the hashes. So both sides will send hashes of their interface IP and port 500. So this one has two hashes, and like we mentioned in the previous lecture, the hashes that it sends is for the IP address of interfaces it has. So here, there's two hashes, one for the loopback and one for interface, gig 00. And then it sends it out to the other side. Okay, so the other side would basically respond back with its own hashes. Okay, so, we don't see actually in the packet capture this calculation. But what happens is that this side will compare the hash from the other side and determine if there's a match. If there's no match, that means the opposite device is behind a NAT device. So here, if we look at the messages, we will see that the exchange is happening. And it will list out that it supports the NAT traversal. This debug shows that it is running the hashes. This is the side that is not behind NAT, but we see it running the hash calculations. Message 5 switches the communication to UDP port 4500 like we explained in the previous lecture. Message 5 switches the communication to UDP encapsulation. And its source port and destination port are 4500. So that's message 5, and message 6 is also using UDP port 4500. And then, so that's phase 1 completed. Now if you look at phase 2, the 3 quick mode messages, they all are coming in and encapsulated within a UDP port 4500 packet. And then those are the ASP packets containing the pings that we did. You cannot, of course, read the packets because it's encrypted. But we see here that those are also encapsulated within UDP port 4500. So hopefully this explained the concepts and showed an example. We will discuss more in the next lecture.